All right, so if we want to do the review, for question one, we're first asked if which relation is not a function. So to figure out if things are functions or not, we have to look at all the x coordinates. So we're looking at all the first numbers. So in this case, if we look at all the x coordinates, we got 0, 1, 2, and 3, and these are all different. Since they're all different, we can already say that that one is a function. Because the only time we would not have a function is if we had two of the same x's and they led to different y's. So if we look at the second one, 3, 5, 7, 9, those are all different again. So that means that's a function also. The third one, here we got 2, 2, 2, 2. So since those are all 2's, that's going to be the one that's not a function. That one's just a relation. Because 2 is going to 1, 2 is going to 3, 2 to 4, and 2 to 5. Remember, each x has to go to 1 and only one y. Just double checking the last one just to make sure. 4, 5, 6, and 7, those are all different. So since the question wants to know which one is not a function, we're going to pick this one because that one's not a function. So pick that choice with the 2's. Now, the reason why it's not a function is because for the x value 2, there are many y values. And that's just one explanation you can give. So I gave that only based on the coordinates themselves. If you want, you could have graphed that and used the vertical line test because we talked about that in class. Or if you wanted to, you could make a function map out of it like we're going to see in a later question, and you can look at the function map. Those are all good choices. All right, for number 2, so here's the function map we were talking about. It says for the map on the left is the relationship of function. So we got to check. So if we look at our x's, because remember, to get a function, each x has to go to only one y. 1 only goes to 1, so we're good. But 2 kind of makes it not a function because it's going to 3 different options. 4 would work out, we're only going to one option, and 10 works out because we're only going to one option. But because of this 2 right here, we have to say no, that's not a function. Now, since it's not a function, we know it's automatically not one-to-one. But if it were a function, if we wanted to check, we would go backwards. So here we could tell it doesn't work out because we've got 2. So that would be not one-to-one. That would be okay. This one's got 2. So we're going 1, 2. And then this one's only got 1, so that one would be okay also. But again, since we knew it wasn't a function, you can already pick no for a relation or for a one-to-one. It has to first be a function in order to even have a chance at one-to-one. Next question we have down there is define the domain. Well, remember, the domain is the x's, so we just have to list all of our x values. So in this case, we got 1, 2, 4, and 10. And then for the range, we want to look at the y values. So in that case, since it's discrete, we're just going to list them all. 12, 20, 24, and 80. So that's the domain and that's the range. Remember, domain is the inputs, it's the x's, it's what's on the left of the function map. Range is the outputs, it's the y's, it's what's on the right of the function map. And that's all the questions for number 2. For number 3, we got a nice table. So here it says the table below shows the relationship between gallons of gas used and the number of miles driven for a new Porsche. So to get the equation, we need 2 things. We need the slope and the y-intercept. So we've done this one a few times. We've done it a few ways. In class, we've been looking at the last numbers, so we may as well just keep looking at the last ones. It'll probably be faster to do something else, but if we do it this way, it will always work. So we need the slope. So we have to do y2 minus y1 over x2 minus x1. So we're going to call this one x1. This one's x2. Down here we've got y1 and y2. So we've got 11 minus 7 over 253 minus 161. Hey, that's not right. That's the x's and the y's. That's fine. We found the mistake really quickly, so we can quickly change it. 253 minus 161 over 11 minus 7. All right, well, 11 minus 7 is 4. So 161 plus 100 would be 261. So we have to go 8 back, so that makes that 92. 92 divided by 4 would be 23. So we know that the slope is 23. So we know we're going to have 23x. Now we also need the y-intercept. So to get the y-intercept, I need to go back to 0. So if I go back to 0, then I'd be subtracting 23. So 23 minus 23 is 0. So I know the y-intercept is 0. And we could actually find that y-intercept a couple of different ways. I know in class we practiced doing it with y minus y1. So y minus 161 equals m, x minus x1, so x minus 7. We know m, so I can actually substitute that in. This is 23. And when we distribute, we get y minus 161 equals 23x minus 161. 7 times 23 is 161. And when we add 161 to both sides, we end up with the same equation that we had before. Y equals 23x plus 0. You don't really need the plus 0 if you don't want to. But since we did the plus 0 in our examples when we were looking at our functions, I kept it there. So there's 2 different ways to do that one question. For the next part, we have to choose a reasonable domain. So again, remember, domain is going to be the x's. So we're only going to look in the gallons used section. Well, if I look at the domain that I'm given, I'm at least given from 1 to 11. So 0 to 5, 5 doesn't go to 11, so I'm not going to pick that one. 7 to 11 doesn't go down to 1, so I'm not going to pick that one. 0 to 15 seems like it might be a good choice. I'm thinking about that one. All real numbers. Well, if it's gallons used, you can't do negative gallons. You can't put negative gas in your car and expect it to go anywhere. So since we can't have negative gallons, we're not going to pick all real numbers. We'll just pick 0 to 15. It is continuous because you could use any fraction in between, but that seems reasonable. Gas tank might be bigger, might be smaller, but that seems reasonable based on our table. And then the final question asks, if 8.5 gallons of gas are used, how many miles were driven? So we want to plug this 8.5 in for x. Now this is the same equation that we had up at the top. I had it down here just so I could see. But we're going to plug it right in. So y equals 23 times 8.5. All right, well, we have to do 23 times 8.5. So let's do that real quick. We get 15, 10, 11, 0, 24, 16, 17, 18. 5, 5, 9, 1. We get 195.5. All right, well, let's use our interpolation to make sure that that makes sense. Is that somewhere between 7 and 11? Yeah, it is. So we're going to go with it for right now. So there we go, 195.5. For question 4, we need an arithmetic sequence. We are not allowed to use d equals 0, so let's just pick something else for d. Let's pick d equals 7, because remember, d is the common difference. D is like the slope. So if I want to, I can add 7. So 39 plus 7 is 46, and that would be what I would be if I went 1 more, because d is the common difference. I don't have to go by 1. If I want, I can go up another 10. I can go as far as I want in my sequence, so this would take me all the way to 17. But then if I wanted to, I would do plus 70 instead of plus 7, so 116. Or if I want, I can just keep going back by 1. That's okay. I can do minus 7, so 32. 32 minus 7 would be 25. Minus 1, so 5 and 4. That's it. So just like we made our tables, we did our Desmos activity where we made tables like this before. You don't have to go up by ones if you don't want to. Usually with the input, it's easiest to go up by ones, but you can choose to do whatever you want. You also don't need to pick 7. You can pick any number except for 0. So the big keys is we have to remember when we're doing an arithmetic sequence, we can't go lower than 1. 1 would have to be the lowest you could choose. And we don't want to have any fractions or decimals in there. We want to only use the natural numbers. So all my numbers are nice whole positive numbers. Output could be whatever you want, but the input, nice positive numbers, nice whole positive numbers. All right, for 5, it says Kelly's working as a valet. She got a $7 tip from her first customer and a $3 tip from every customer afterwards. We have to write an explicit formula for the situation. So we have to remember explicit formula. That formula is a sub 1 equals, not a sub 1, a sub n, thinking ahead of myself. A sub n equals a sub 1 plus n minus 1 times d. All right, well, remember, a sub n never changes. A sub 1 is always what you start at. Well, it looks like the first thing that she gets is a $7 tip for her first tip. So this is the first tip. So this is a sub 1. So we get a 7. Plus n minus 1 never changes. So that stays the same. And then we need d. Well, d is the common difference. So d is how much it goes up by every time. So every other time, it's a $3 tip. So we have to do times 3. And that's it. That's all we have to do is just make the equation. We don't need to plug anything in for it after that. We just want to get the equation. The question afterwards says to convert the explicit formula to a recursive formula. Well, the first thing it says is a sub 1 equals. Well, a sub 1 is 7. So that's how we want to fill out the first one. And then the second one is the actual form of the equation. A sub n equals a sub n minus 1 plus, and we want to put d in for that value. So for 3. So remember, this value is always going to be whatever d is. That's what number that is. If you're decreasing, then it would be, instead of a plus 3, you could say plus negative 3 or minus 3. That's an explicit to recursive formula. All right, for the next one, it says to draw the trend line for the data and then create an equation for the line that we made. So on Desmos, if you hit the little line tool here, so this little line tool, you're actually allowed to just make a regular line. So your line would just come out with a nice straight line. So I'm thinking that looks good. Again, your line might be a little different because this is a trend line. So trend lines, they have chance for variance. But the next part says to create an equation. So for my equation, looks like I'm doing pretty well because I've got my y-intercept already is at 1, because that point is at 0, 1, which is also going to be my x1 and my y1. And I want to look at the black line that I drew and see if I can find another point somewhere where I'm also on the grid. And it looks like right here, that looks like I'm on the grid there. It looks like that's at 5, 1. So I'm going to call that x2 and y2. So again, I didn't pick any of the green dots. The green dots weren't really good ones to pick because they're not really on the grid. This one might be, but I didn't go through that one. So I'm going to pick something that's on the trend line because I want the equation of the line, not the equation of the dots. So to get the slope, we could do y2 minus y1. We could also just count the slope if we really wanted to. And we can tell we're going up 1 over 5. So if you wanted, you could get to 1/5 right away. I'm going to go through the whole formula though, because the formula will always work. y2 minus y1 over x2 minus x1. So we get 1, oh, that's a 2. So 2 minus 1 over 5 minus 0. And so again, we get 1 over 5. Now you don't have to turn that into a decimal if you don't want to. I'm going to leave it as a fraction for right now. I'll change it later if I need to. So we're going to use y equals mx plus b, since we know m the slope and we know b the y-intercept. So y equals 1/5 x, v is 1, so plus 1. So I got my equation. The other question on this page just asks what type of correlation we have. So I've got a positive slope, so I'm going to pick positive. Probably should have did that in blue. Let's do that in blue. So I'm going to pick that as positive because m is positive. So remember, a negative slope would look like that. That's not what we've got. And no slope would probably be flat. Or if the dots just kind of went all over the place, then you could also have none. Random would also work out as a none. All right. For question 7, it says Debbie made a budget predicting the amount of money she would spend before her next paycheck. Fill in the residuals below, then answer the questions. So to do residuals, we got the residual formula. So we just did this one recently. So residuals is the actual minus the predicted. So we have to see, okay, well, the actual is going to be the actual amount of money that she spent. So the money that she spent is the actual. The predicted is going to be her budget because that's how much she thinks she's going to spend for that day. So let's see. If we spend 150, but we budgeted for 200, when we subtract those, we end up at negative 100. And that's okay. So she over budgeted, which is good because that means that she's got some extra money. She has $100 extra. For 6, we're at 230. She budgeted 450. So we subtract those. Okay, it looks like we get, that can be negative 220. I think so. All right, so she's still way over budgeted, which again, still fine. Over budget, maybe she needs to fix her budget a little bit because that's kind of very far off, but still okay. And then if there's 3 days left, again, we have to do subtraction, actual minus predicted. So now we see the residual is $100, which means she spent $100 more than she expected to. So something must have happened between day 6 and 3 that she spent a lot of money, because now she's over her budget. So she should watch out because maybe she doesn't have enough money until her next paycheck. But we filled in all the residuals. So if we look at the amount of money she spent, how much do we estimate she spent when there were 5 days until her paycheck? So we know 5 is inside of 6 and 3. So we have to pick a number for the money that she spent that would be somewhere in between here. So essentially anything between 230 and 700 would be okay. I'm just going to pick 400. But anything in between would be okay because we don't know. Maybe she spent a lot of money on day 5. Maybe that's when she spent all the money. It could be, 700. Maybe she spent not very much. Maybe she's only spent $20, so she's at 250 and she's going to spend the most of her money on day 4 or day 3. But as long as we pick something in between, we're good to go. And this is going to be interpolation because we were trying to pick between two numbers we know. Extrapolation would be if I want to know like 11 or like 1, because that would be outside of the data that we know. And that's it for number 7. So the final question, we're given a table for calories eaten at lunch and student weights. We have to decide which R value is most appropriate. So an R value of 1 means things are like perfectly in a arithmetic sequence. But I don't think we are perfectly in an arithmetic sequence because here we go up by 50 and we go up by 2 pounds. Here we go up by 100, so I would expect there to be a 4-pound increase, but there's not. There's a 12-pound increase. So it's not perfect, so we're not going to pick R as 1. That would be if all the dots were exactly in a line. It looks like as the calories go up, the weight goes up. So I'm not going to pick something that's negative, because the two variables would have to have the opposite relationship. So I have to decide between 0.991 and 0.091. Well, it does look like for the most part, as the calories go up, the weight goes up. So I probably want to be close to 1. So I think I'm going to pick this one, since the variables look like they're pretty well related. As the calories eaten goes up, it looks like the weight tends to go up. So I'm going to pick that one, and that's very close to 1, so I'm going to make that a strong correlation. Does that show causation? Well, no, it does not. Correlation, yes, but causation, no. Because the calories you eat at lunch is not always going to determine your weight. There's a lot of things that can determine your weight. So to justify my choice, I could state that, but I could also state that, sometimes people eat a lot at lunch and then go work out and they burn off all those calories. So that's going to be one of my things that would be something that would show it's not causation. So someone could eat a lot, then go work out, and burn the calories. We'll say use the calories. And so that would be one example of why this isn't always going to be true. So if you think about it, if you play sports, sometimes you want to eat a lot of food right before, not right before, but before a game. That way you have a lot of energy for the game. And then maybe you spend all that energy while you're playing your whatever sport you want to play. So this is not always true. So even though the data looks like for the most part it's true, it's not always true 100% of the time.